Microsoft Security documented a case where an attacker hid instructions inside of a GitHub issue, knowing that a Claude coding agent would read it. The agent was running as part of a GitHub Actions workflow. It could search the repository, read files, and create a pull request. A maintainer would normally read these issue texts as collaboration content. For the agent, this was also an input to a process with repository permissions. The hidden instructions pointed the agent at a documentation file. The agent then used its tools and opened a pull request containing a malicious change. If that pull request were to be merged, the documentation site could run attacker-controlled JavaScript in the visitor's browser. The attacker had moved from text in an issue to real code changes proposed by an agent that has repository access. That pull request did not go live by itself. A maintainer or another automated step still had to merge it. Microsoft did not report that this actually happened. Microsoft also didn't report that the change reached the site or that any visitors were actually compromised. This merge gate matters because this was not an agent silently deploying an attack. It was an attacker getting an agent to propose the malicious change. We're usually careful and looking for dangerous changes when untrusted code gets executed. But a GitHub issue is different because it is supposed to be read. The agent did its job by reading the issue, but it also treated part of the issue as an instruction. The text alone could not change the repository. Where it becomes dangerous is the combination of this untrusted text along with an agent that has permissions to act on it. Git inject is a recent research project that tested hidden instructions against coding agents inside real GitHub workflows. The researchers found attacks that simpler simulations had missed. Those simulations did not reproduce the same credentials, sandbox rules, and repository states. So the model matters, but so does the environment around it. Microsoft also found that the agent could read the workflow's environment variables from a Linux system file. This could expose the Anthropic API key and possibly other credentials on the runner. Anthropic mitigated this specific path in Claude Code 2.1.128. Regardless, this example still shows how sensitive access changes the possible impact of a bad instruction. Microsoft calls this the agent's rule of two. A single workflow should not combine all three of these at the same time: untrusted input, sensitive access, and tools that can change state or communicate externally. An agent may need some of these to be useful, so the rule is just to avoid combining all three in a single workflow. Remove or strongly limit at least one of these. That can mean more limited credentials, one writable branch, restricted network access, or an independent review before a PR is merged. Better models may reject more malicious instructions, and filters can remove some hidden content. Those are useful defenses, but I personally don't want either to be the main permission boundary. If an agent reads issues, pull request descriptions, repository files, or tool output, I want the system around it to assume that some of the context may be hostile. Then I want its access limited, so a proposed change cannot become a deployment by itself, and a bad instruction cannot reach a runner's secret. When I look at an agent workflow now, I ask one more question: what can this process reach after the model gets something wrong?